Hello students, today we shall discuss the basic concepts of chemistry questions based on the mole concept. So the first question here is, how many carbon atoms are present in 0.35 mole of C6H12O6? C6H12O6 is having 6 carbon atoms for each molecule. If you take 1 mole of C6H12O6, then there must be 6 moles of carbon atoms. But given is 0.35 mole. So 0.35 mole of C6H12O6 must have how many number of the carbon atoms? So just do the cross multiplication. 0.35 into 6 mole. Mole value is 0.35 into 6 into 6.022 into 10 power 23. This is the Avogadro's number. So if you solve all this, you will get the 1.26 into 10 power 24 carbon atoms. So option C is correct. Let us solve the question number 2 now. How many molecules are present in 5.23 grams of glucose? Glucose C6H12O6 molecular weight is 180 grams per mole. So number of moles of the glucose equals to weight by molecular weight formula. Given weight is 5.23 grams, whereas molecular mass is 180 grams per mole. They are asking how many molecules are present. So number of molecules formula, number of molecules equals to number of moles into 6.022 into 10 power 23. Number of moles value here it is 5.23 divided by 180, here grams, here it is grams per mole, into 6.022 into 10 power 23. So the answer for this question is, if you calculate everything, you will get the 1.75 into 10 power 22. So option B is correct. Now let us solve the question number 3. What weight of 3.01 into 10 power 23 molecules of ammonia? So let's try to see the formula. Number of moles equals to, we know that weight by molecular weight if mass is given, or else given number divided by Avogadro's number, that is 6.022 into 10 power 23. So from this you will get the number of molecules. But we want to get the weight. So this particular form can be converted into the weight equals to number of moles into molecular mass. In the place of number of moles, we can introduce this particular form, that is a given number divided by Avogadro's number into molecular weight. So here given number is 3.01 into 10 power 23 divided by 6.022 into 10 power 23 into molecular mass of the ammonia is 17. So it goes almost 2 times and it goes almost 8.5 times. So weight of the substance is 8.5 grams. So option B is correct. Now let's try to solve the question number 4. According to the question, 8 liter of hydrogen and 6 liter of chlorine are allowed to react to maximum possible extent. Find out the final volume of reaction mixture. Suppose pressure and temperature remains constant throughout the course of the reaction. First of all, let's try to write down the balanced chemical equation. H2 reacts with Cl2 and giving the 2HCl. So according to this question, if you see, one volume of hydrogen reacts with one volume of chlorine and giving 2 volumes of HCl. So it is a 1:1 reaction, but given values are 8 liters of hydrogen, 6 liters of chlorine. So chlorine is available in the less extent, so less amount. So that is the reason why 6 liters of chlorine can react only with the 6 liters of the hydrogen. So out of 8 liters, 6 liters of the hydrogen participate in the reaction. Still 2 liters of the hydrogen is present. So now 6 liters of the hydrogen combines with 6 liters of the chlorine, and they are able to produce the 12 liters of HCl. But they asked about the volume of the complete reaction mixture. So reaction mixture means hydrogen and HCl together. So total volume becomes now 14 liters. Hence option B is correct. Let us solve the question number 5. You must see that if these questions are not visible, the question paper is available in the description box. You can download it. Then you can take the printout, and you can see the solutions in the video. You can pause the solutions video for some time and copy the solutions, and then you can proceed for the next question. So naturally occurring chlorine is 75.53% of chlorine 35. So percentage of chlorine is, this is 75.53, and isotope is chlorine 35, which has the mass, an atomic mass is given, that is 34.969, and another isotope is given, that is 24.47%. 1 minute, I'll write this side. Second isotope percentage is 24.47%. This is of chlorine 37, whose atomic mass is closely to the 36.966 atomic mass units. They are asking us to calculate the average atomic mass of the chlorine. So average atomic mass formula is, I will just take average atomic mass is equals to percentage of isotope into its mass. For the first isotope, this is plus percentage of the second isotope into its mass. Divided by total percentage. Total percentage anyhow it is equals to 100%. So let's try to substitute this form. First isotope percentage how much? 75.53, and its mass is 34.969. Plus second isotope is 24.47%, and its mass is 36.966, whole divided by total percentage is equals to 100. So if we solve this particular everything, we get the answer of approximately 35.5 atomic mass units. So option A is correct. Now let's try to solve the remaining questions. Question number 6. So the question is, calculate the mass in gram of 2 gram atom of magnesium. You must remember that 1 gram atom. So throughout this lesson, 1 gram atom means 1 mole. That you must remember. So 1 mole of 2 gram atom means 2 moles. 2 gram atom is equals to 2 mole. So here 1 mole of magnesium atomic mass is equals to 24 grams. Then 2 moles of magnesium atomic mass must be equals to 48 grams. Here answer is not there, so this is the answer. That is none of the above. Now question number 7. In 5 gram atom of silver, calculate the weight of 1 atom of silver. we no need to consider the 5 gram atom, just let us consider the only 1 gram atom, 1 mole silver mass. So 1 mole of silver atomic mass, that is atomic mass, 1 mole of mass of 1 mole of silver means it is nothing but atomic mass. So 1 mole of silver mass is equals to 108 grams per mole. So 1 mole means here 6.022 into 10 power 23 number of silver atoms mass is equals to 108 grams. Then 1 silver atom mass must be equals to how much? So here we can write mass of 1 Ag atom is equals to, just do the cross multiplication, 108 divided by 6.022 into 10 power 23. So this is equals to 108 into 1.66 into 10 power minus 24. And still if you do the calculation of this, you will get the 17.93 into 10 power minus 23 grams. So option, this is option A is correct. Question number 8. The question is, a compound possesses 8% sulfur by mass. The least molecular mass is, see, percent is always for 100. So means 8 grams of sulfur is present in 100 grams of that molecule. They said the least mass, the least molecular mass means at least if you think that one sulfur atom is present. So one sulfur atom mass is 32 grams. So at least one sulfur atom is present. So 32 grams of sulfur may present in how many grams of the molecule? So that mass of the molecule that they are saying is a molecular mass. It is 32 into 100 divided by 8. It goes almost 4 times, that is equals to 400. So option B is correct. Now let's try to see the question number 9. Calculate the mass in grams of 2Na, means 2 molecules of CO2. See, 1 mole of CO2 mass is equals to 44 grams per mole. Then 2Na means 2 moles. 2 moles of CO2 mass must be equals to just double grams, 88 grams. So here it is 88 grams. Let us solve the question number 10. So in question number 10, in a mole of water vapor at STP, the volume actually occupied or taken by the molecules is, see, we know that 1 mole of any gas occupies how much volume at STP, that is 22.4 liters. But according to the kinetic molecular theory of the gases, gas molecules are arranged very much apart from each other. So if you condense all these molecules, they occupy even less than 1% of this 22.4 liters. Hence option B is correct. Let's try to solve the question number 11. How many molecules are present in 1 ml of water vapors at STP? So 1 ml means 1 mole of the water. We know that 1 mole of the water vapor, 1 mole of H2O vapor. Vapor means a gas in gaseous state. It occupies at STP 22.4 liters. 1 mole contains 6.022 into 10 power 23 number of H2O molecules occupy 22,400 ml of volume. Here liters are converted to the milliliters, but they are asking about the 1 ml of water. So 1 ml of water can contain how many number of the water molecules? So here number of water molecules equals to, simply just do the cross multiplication, 1 ml into 6.022 into 10 power 23 divided by 22,400. So that if you solve everything, here we'll get the 2.69 into 10 power 19. So option D is correct. So question number 12. How many years it would take to spend Avogadro's number of rupees at the rate of 1 million rupees in 1 second? So first of all, let's try to write down 1 million. So 1 million, or it is equals to 10 power 6. So these many rupees they are spending for each second. Then Avogadro number of rupees 6.022 into 10 power 20, the number of rupees can be spent in how many seconds? So we'll get the seconds initially, that is 1 into 6.022 into 10 power 23 divided by 10 power 6 seconds. But the seconds are to be converted to the years because the answer is in the years only. So here we have to just divide with the years, hours, minutes. So that now 1 into 6.022 into 10 power 23 divided by 10 power 6 into, we know that each second, 1 minute is having the 60 seconds. So that we will write down here 60 into 60 into 24 days into 24 hours into 365 days. So if you solve this, we will get the 19.098 into 10 power 9 years it will take. So option C is correct. Let's try to solve the question number 13. An atom of element weighs 6.644 into 10 power minus 23 grams. Calculate the gram atoms of element in 40 grams. So here let's try to calculate. They are asking how many gram atoms are present. Calculate the gram atoms. Gram atoms are nothing but the number of moles. So number of moles formula, weight by atomic weight. Here atom is given, no, atomic weight. This weight must be in the grams, atomic weight also must be in the grams. Weight is given how much? 40 kg is given. So I'll convert this kg into the grams. So 40 into 10 power 3 grams. And next one, atomic mass. Here each atom, single atom mass is given. So that is 6.644 into 10 power minus 23. But this one atom, if multiplied with Avogadro number, then you will get the 1 mole of atom. Atomic weight is always for 1 mole, not for one atom. So it is equals 10 power 23. It get cancelled. This is approximately equals to 40. So these values get cancelled out. So finally you will get the 10 power 3. So option C is correct. Let's try to solve the question number 14 here. Calculate the number of Cl minus and Ca plus 2 ions in 222 grams of anhydrous CaCl2. First of all, let's try to write down the molecular weight of CaCl2. Molecular weight of CaCl2 equals to 111 grams per mole. But given mass is 222 grams. So let's try to find out the number of moles of CaCl2. So number of moles of CaCl2 equals to given mass by molecular mass. Given mass is 222 grams divided by this is 111 grams per mole. So that you will get the grams also get cancelled. You get the 2 moles. 2 mole can be written as 2 into Na. Okay. So here 1 mole of CaCl2 will have the 1 Ca plus 2 ion. 1 mole of CaCl2 can release 1 Na of Ca plus 2 ions. Then 2 Na 2 Na of CaCl2 will have 2 Na of Ca plus 2 ions. So regarding Ca plus 2 ions, it is 2 Na. They are asking even about the Cl minus ions also. So here each CaCl2 is having the 2 Cl minus ions. Then 2 Na of CaCl2 will have how many Cl minus ions? 2 Na into 2 Cl minus, and that means 4 Na of Cl minus ions. So option regarding the Cl minus and Ca plus 2, none of these options are actually correct, as they did not mention respectively. So we can pick up this. Okay, sorry, it is given 2 Na of Ca plus 2 ions and 4 Na of Cl minus ions. Option A is correct. Question number 15. Calculate the weight of lime CaO obtained by heating 200 kg of 95% pure limestone CaCO3. So the limestone itself is only 95%. So let us try to see here. Percent is always for 100. So 100 grams of CaCO3, impure CaCO3, this is impure. Impure CaCO3 contains only 95 grams of pure CaCO3, because 95% pure. Here they had given 200. Let us consider here it is a 100 kg, here also 95 kg. Now let us consider it is a 200 kg. Then 200 kg of impure CaCO3 will have how much mass of the pure CaCO3? So pure CaCO3 is equals to 200 into 95 divided by 100. So it is equals to the 190 kg. This is first step. And in the second step, we know that CaCO3 on heating, it decomposes to the CaO plus CO2. Molecular mass of CaCO3 is 100 grams per mole and CaO is 56 grams per mole. Let us consider this 100 grams as 100 kg. If it is 100 kg, it becomes 56 kg. So 100 kg of pure CaCO3 is giving 56 kg of the CaO. Then according to our calculation, there is 190 kg of pure CaCO3. So it can give how much mass of the CaO. So just do the cross multiplication, that is 56 into 190 divided by 100. This is 190. So this is equals to 106.4 kg. So option D is correct. Question number 16. The chloride of metal has the formula of MCl3. MCl3. So according to this formula, metal is having +3 oxidation state. The formula of its phosphate will be, phosphate ion formula is PO4 -3, and here metal is having +3. So one metal is enough to neutralize this particular negative charge. So that formula becomes now MPO4. Answer B is correct. Let's try to solve the question number 17. A silver coin weighing 11.34 grams was dissolved in nitric acid. When sodium chloride was added to the solution, all the silver, whatever present in the form of AgNO3, was precipitated as silver chloride. The weight of the precipitated silver chloride was 14.35 grams. Calculate the percentage of the silver in the coin. So let's try to calculate the number of moles of the silver. First of all, try to understand this question. There is one silver coin. So this silver coin is subjected to the HNO3, and all the silver is converted to the AgNO3, silver nitrate. And this silver nitrate later subjected with the sodium chloride, so that all the silver nitrate converted to the sodium chloride. And how much mass of the sodium chloride is formed? It was 14.35 grams of sodium chloride, silver chloride was formed, and silver coin mass is actually 11.34 grams. This is initial mass of the silver coin. Is the finally silver is converted to silver chloride and the total mass is 14.35 grams according to the question. And molecular weight of the silver chloride AgCl is equals to 143.5 grams per mole. So let's try to find out the number of moles. Step 1. Number of moles of AgCl weight by molecular mass. So that is 14.35 divided by 143.5. It is equals to 0.1 mole. So whatever the silver is present here, the same number of moles of silver also present in this silver coin. So number of moles of silver is equal just 0.1. So second step is number of moles equals to weight by atomic weight. Let's try to find out the weight of the silver present in the silver coin using the number of moles. So weight equals to number of moles into atomic weight. Number of moles is 0.1. Atomic mass of the silver is 108. So it is equals to 10.8 grams of silver is present in the silver coin. Now let's try to calculate the percentage of the silver present. So percentage of the silver means the total amount of the silver present divided by the total mass, that is 11.34 into 100. So here we shall get the approximately 95.2 percentage. So option B is correct. Let's try to solve the question number 18. Phosgene, a poisonous gas used during World War I, contains 12.1 percentage carbon, 16.2 percentage oxygen, 71.7% chlorine by mass. What is the empirical formula of the phosgene? Phosgene itself is a COCl2 gas. Directly you can answer this question. Even if you phosgene formula is COCl2, so no other empirical formula is present for the phosgene. But anyhow, if you want to solve the question, just write down the element. This is element given percentage and take the ratio, that is called as mole ratio. Then you take the simple ratio. So element is carbon, second one is oxygen, next one is chlorine. Carbon given as 12.1, oxygen is 16.2 and chlorine is 71.7 percentage. And mole ratio means just divide with their atomic masses. 12.1 by 12, this is equals to 1.01, and 16.2 by 16 is equals to 1.01, and 71.7 divided by 35.5 is equals to 2.02. So just divide all these with their simplest ratio. So 1.01 divided by 1.01 equals to 1. Here also 1.01 divided by 1.01 equals to 1. That is 2.01 divided by 1.01 is equals to 2. So carbon 1, oxygen 1, 2 chlorines. So empirical formula is COCl2. Option A is correct. So let's try to solve the question number 19 now. The question is, what volume of hydrogen gas at 273 kelvins and 1 atmosphere pressure will be consumed in obtaining 21.6 grams of elemental boron? Atomic mass of boron is given 10.8 from the reduction of boron trichloride by hydrogen. So first of all, let's try to find out the number of moles of the boron that they obtained. This is given weight by atomic weight. Given weight is 21.6 divided by atomic mass is 10.8. So number of moles of the boron obtained is equals to 2 moles. So let's try to write down from which molecule they are getting this boron trichloride. So BCl3, let's try to write down the balanced equation. Reacts with hydrogen and giving the atomic boron. All these Cl will be converted to the hydrogen chloride, so that we will get the 3HCl. So 3 hydrogens are there, so we can write 3 by 2. Means 3 by 2 mole of H2 is giving 1 mole of boron. Then according to this form, 2 moles of the boron will be obtained from how many moles of the hydrogen? So number of moles of hydrogen is equals to 2 into 3 by 2 equals to 3 moles. And they are asking what volume of hydrogen gas. So number of moles of hydrogen is 3 moles. Each mole of this hydrogen occupies 22.4 liters. So if we solve everything over here, we shall get the 67.2 liters of hydrogen. So option C is correct. So let's try to solve the question number 20. Which of the following will weigh maximum amount? So directly they are asking the mass. So first option is mass of iron equals to 40 grams is given directly, and second B is 1.2 gram atom. Gram atom means mole, so 1.2 mole of nitrogen they are asking. So we know that number of moles equals to weight by atomic mass in the case of the atoms. So weight equals to number of moles into atomic weight. So number of moles how much? 1.2 into atomic mass is of nitrogen is equals to 14. So I am going to calculate here mass of nitrogen. Mass of nitrogen equals to 1.2 into 14, that is equals to 16.8 grams. And option C is they are asking these mean number of atoms, carbon mass is. Similarly again number of moles equals to given number divided by the Avogadro number Na. And if whenever you want to calculate the mass, there is one more formula, number of moles equals to weight by atomic weight. We want the weight, so weight equals to number of moles into atomic weight. So when number is given, this number can be introduced into the number of moles. So it is equals to given number of moles divided by the Avogadro number into atomic weight. So straight away use this formula. So weight of carbon is equals to given number is 10 power 23 divided by Avogadro number 6.022 into 10 power 23 into atomic mass is 12. So it get cancels out. So it approximately goes to the 1.99 grams. And next last one is 1.12 liters of O2 at STP. Here also same. If you want the weight, number of moles into atomic mass. So number of moles means here you can write in the, if volume is given, that is given volume divided by 22.4 into if molecule is given, you take the molecular mass. If atom is given, you take the atomic mass. But here oxygen is given the molecule, so that I have taken the molecular mass. So how much volume? 1.12 liters. So weight of O2 is equals to number of moles of O2 into molecular weight. Number of moles is given volume is 1.12 liters divided by 22.4 liters into molecular mass is 32. So together it is equals to 1.6 grams. So among all these, which is having the highest mass means that is 40 grams 20. Dear students, hope you understand. This question paper is available in the description box. Even other videos also, their links are available in the description box. So I request you all, please share these videos as much as possible, like the videos, and if you whatever the concepts you want, you please try to comment in the comment box. Thank you one and all.